class 12 solid state chemistry. Actually, in today's class, we are going to discuss types of crystalline solids. Last day we understood that solids are of two types, crystalline and amorphous. Today we are going to discuss what are the types of crystalline solids. So the first one is molecular. Molecular. Now molecular crystalline solids, they can be considered in three categories. First is non-polar. So you understand the word polar, non-polar we only use for covalent compounds. So non-polar, they will only have dispersion forces between them because they are non-polar. You remember dispersion forces, they are also called London forces. We had that in states of matter of class 11. And examples are argon, CCl4, hydrogen, iodine, CO2. So these are all non-polar molecular crystalline solids, right? And they are very soft to touch, they are insulating, they are insulators, and they have a very, very low melting point. So this is molecular subcategory 1, non-polar. Now it is very uncharacteristic of us to imagine that hydrogen is a solid. So that means at very low temperature it will be. Otherwise, they are generally liquid or gaseous at room temperature. So at room temperature, they are generally either liquid state or gaseous state, because it's very unlikely that we will ever imagine hydrogen to be a solid. So that is true. They are generally liquid or gaseous at room temperature. Next we come to category number 2. Category number 2 is polar. So polar molecular solids, they have dipole-dipole interactions, and examples are HCl and SO2. Okay, they are soft, they are insulating, and they have low melting point. So polar means they will be molecular, but they will be polar. They have dipole-dipole interactions like HCl and SO2. They are also soft to touch, they are also insulating, and they have low melting point. Actually, here you can add another example, solid ammonia. So otherwise, they are also mostly liquid or gaseous at room temperature. So that is number 2. Number 3 is hydrogen bonded molecular. So their interactions are through hydrogen bonding. So their interactions are through hydrogen bonding, and example you can say ice, chemically it is H2O. Now they are not soft, they are hard. They are insulating, and they also have low melting point, right? They are comparatively hard. They are insulating, and they are generally either volatile liquids or soft solids. So at room temperature, Generally, they are either volatile liquids or soft solids. So this is the three categories of molecular solids. So once again, molecular solids, they are of three categories. As the name suggests, the solid is made up of molecules. So they can be non-polar, like argon, CCl4, H2, I2, CO2. The only forces between the molecules are dispersion forces, which we also call as London forces. They are liquid or gaseous at room temperature. They are soft, insulating with very low melting point. Polar has got dipole-dipole interactions, HCl, SO2, ammonia. They are soft, insulating and low melting point. Hydrogen bonded, they have hydrogen bonding between them. Example is ice, which is chemically H2O. They are hard, but they are insulating with low melting point. And as compared to non-polar and polar, they are volatile liquids or soft solids at room temperature. Next we go to ionic solids. So ionic solids are actually made up of ions. And the forces are Coulombic forces. NaCl, MgO. ZNS and CaF2. So the examples are NaCl, MgO, ZNS and CaF2. They are hard but brittle. Now in solid state they are insulators. But in molten state or aqueous solution, they are conducting. And the melting point is very high. Okay, so in solid state they are insulators, but in molten state or aqueous solution they are conducting and melting point is high. So this is regarding ionic solids. Then we come to category number 3, that is metallic solids. Category number 3 is metallic solids. So metallic solids is positive ions in a sea of delocalized electrons. So metallic solids are positive ions in a sea of delocalized electrons. And what is the kind of bonding? It is metallic bonding. So examples are Fe, Cu, Ag and Mg. So they are hard, malleable and ductile, and they conduct in solid state as well as molten state both. So this is a very big difference between metallic solids and ionic solids. Ionic solids in solid state they don't conduct, but in molten state and aqueous solution they conduct. And metallic solids in solid state, molten state, both the state they conduct. And the melting point of ionic solids is high. This one also, the melting point is high. So this is metallic solids. Then covalent or network solids, so they are made up of atoms. This with covalent bonding. So example is SiO2, which is also called quartz. Another example is silicon carbide. SiC, silicon carbide. Then you have carbon in the shape of diamond, and you have aluminium nitride. You have carbon in the shape of graphite. So these are the examples. All of them are hard, but only graphite is soft. Graphite is not really known for its hardness. Another thing is that they are insulators, and graphite is an exception. Graphite is an exception, it is a conductor, and the melting point is very high. So covalent or network solids, the example is SiO2, which is also called quartz, silicon carbide, then carbon in the form of diamond, aluminium nitride, carbon in the form of graphite. These are all hard, graphite is soft. They are insulators, but exception is graphite, their melting point is very high, right? Now what is a special feature of these covalent network solids? Actually what happens is that in these solids, the individual atoms are held together in a 2D or 3D network, and there is a rule that if the network is there is a rule that if the network is 2D, then it will be a rigid network, but if it is 3D, it will be even more rigid, which explains the huge difference in the rigidity of graphite and diamond. In fact, graphite is soft compared to diamond. Diamond is very hard because it has got 3D network, and graphite has got 2D network. And the fact that so what happens is that the individual atoms, they form covalent bonds with each other, and these covalent bonds, depending on whether 2D or 3D network, that will increase the rigidity. If it is 3D, it will be more rigid. So now what happens is that in case of diamond, the hybridization is sp3, so it is a 3D network, but graphite is 2D, so hybridization is sp2. So as a result, in carbon, there are 4 valence electrons, so hybridization is sp2, so the 4th electron, it is free to move, and therefore as an exception, graphite is a conductor. So there is a reason why graphite is a conductor, because the 4th electron is free to move and it is delocalized in the structure of graphite, and that is why graphite is considered a good conductor. And one more thing is, because graphite has 2D layers which are separated by some distance, so the 2D layers can slide between each other, and that is the reason why graphite is a soft solid, and it is also sometimes used as a solid lubricant. So these are the total details of different type of crystalline solids, and now as usual I'll give you the homework. Okay, these are the 4 homework questions. First question is classify. Classify means you have to say, is it molecular, is it covalent, is it ionic, is it metallic. If it is molecular, you have to say, is it polar molecular, non-polar molecular, hydrogen bonded molecular, like that. So classify: potassium sulfate, tin, benzene, urea, ammonia, water, zinc sulfide, graphite, rubidium, argon and silicon carbide. You have to classify them. Question number 2, there is a solid A which is very hard. It is insulator in both solid state and molten state, and it melts at a very high temperature. What is the type of solid? Question number 3, why ionic solids conduct in molten but not in solid state? Right? Why ionic solids conduct in molten but not in solid state? Question 4, which solids are conductors, malleable and ductile? So these are the 4 homework questions, and we will continue with solid state in the next session. We will do geometry of the crystals. That will be the topic for the next session. So I'll conclude the session. Thanks a lot and meet you in the next session. Please do the homework by 9 p.m. Thursday. Bye all of you.